so I'm going to move on now to the second prompt, which is labeled more probability practice. Okay, and we're just going to kind of expand on that. Instead of drawing 2 marbles, now we're going to move into 3. Okay, because we're making more draws, of course, that's going to mean we have more possible combinations that we can make here. Okay, so let's start out. Nothing has changed. Our random variable is still going to be X, and it's still going to count the number of blue marbles we select in a random process of drawing 3 marbles. Okay, we're going to draw one, record its color, put it back, draw another, record its color, put it back, and draw another. Okay, and in that 3, then we're going to count how many blues resulted in that combination. Okay, so what are the possible values of X? Okay, so if I'm drawing 3 marbles, how many could I possibly count that would be blue? Okay, now I had a lot of students say, well, if this would be red, would you be able to do this problem because there's only 2? Sure, I would, because remember, I'm replacing them and putting back. So it wouldn't matter if there were only 2. It would be possible to draw 3 red because we'd be putting back. We're not drawing red, though. We're drawing blue. Okay, so what are the possible values of X? Okay, before we start thinking about that, okay, if we're thinking about the possibilities of values of X, I could have none of those 3 could be blue, 1, 2, or all 3 could be blue. And that's the possibilities. I'm not going to include those in my table right now because I want to assign that to each specific outcome. Okay, now notice that there's space underneath here. This would be a good place to draw your probability tree. So I'm going to think about marble number 1. It could be red or it could be blue. And here that's a 2/5 probability and a 3/5 probability. No matter when we draw, these are our associated probabilities. Okay, we didn't change anything yet. There's still 3 blue and 2 red. Okay, so this is draw number 1. And now, no matter what happens in that first draw, no matter whether we got a red or a blue, it is possible for me to get a red or a blue in the second draw. Again, blue would be another 3/5 probability. Red would be 2/5. Okay, so each time we write these down, that probability applies, or each time we draw these. So this is draw number 2. So get into draw number 3. I'm talking about red and blue. Red and blue. More red, more blue. All right, so what we've really created here, okay, we had 2 choices, we did 3 draws. We should be looking at 8 outcomes, which we are. Red, 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 blue, red, blue, red, red, blue, blue. 4 outcomes, okay? So let's write those down. Red, 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 oops, that looks too much like a B. Red, red, blue, and red, blue, red, and red, blue, blue. Okay. And then the value of X. How many blues are included? 0, 1, 1, 2. Okay. Now let's go over here. Let's look at these outcomes. Blue, red, red, blue, red, blue, 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 red, and blue, blue, blue. Let's write those down. Blue, red, red, blue, red, blue, 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 red, and blue, blue, blue. Here, if I'm counting blues, that's 1, 2, 2, 3. Okay. And let's think about the probabilities of each one. Okay, and red, 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 that's 2/5 times 2/5 times 2/5. 2 times 2 times 2 is 8. 5 times 5 times 5 is not 15, is 125. So we have 8 over 125. And if you're looking as to where that calculation comes from, okay, remember, this is an and situation. I want all 3 of these to be red. So I have to multiply them. That's independent events, probability, so multiplication, okay? Now when I go to red, red, blue, 2/5 for the red times 2/5, which would be 4/25, okay, times 3/5 for that blue. Okay, so 12 over 125. Here, I have 2/5 times 3/5 times 2/5. Now, guys, I already know that this is all in fifths, so I know all of the denominators are going to be 125. What I'm going to think about now is the numerator, and that comes from the probability of each marble. So 2 times 3 is 6, times 2 is 12, so here's another 12 over 125, okay? 2/5, 3/5, 3/5. 2 times 3 is 6, times 3 is 18, so that's another 18 over 125. Here, 3/5, 2/5, 2/5. 3 times 2 is 6, times 2 is, here's another 12. Here we have 3/5, 2/5, 3/5. So 6 times 3 is 18. And I'm going to keep going. So blue, blue, red. 3 times 3, 3/5, 3/5, 2/5. So 3 times 3 is 9, times 2 is another 18 over 125. And last but not least, 3 times 3 times 3/5. 3/5, 3/5, 3/5. So 3 times 3 is 9, times 3 is 27. Okay. So let's try to expand that now. We know that we can have 1, 2, or 3. All of these are possibilities for the number of blue when I select 3 marbles. So let's look at the outcomes. There's only one outcome where there's no blue, and we see it right here. Okay, that's the red, red, red. And it had a probability of 8 1/25. Okay. Now, one that's a little bit different because there's here, here, and here. All of these produced 1. So we have to combine these. We have 12 plus 12 is 24, plus another 12, that's 36 over 125. Let's go look at the 2s. I have here, here, and here, okay, which would be 18, 18, and 18, okay? So if I added those all together, I'm going to get 54. Uh-oh, what happened? Did I take away something here accidentally? Let's look at my 2s. I had 36 out of 125, and then I had 54 out of 125. Okay, and then last but not least, I'm going to look at the probability of 3. Notice it's not equal to 2. Why doesn't that happen? They both had one outcome, but they're not equally likely because there's more blues in there. I'm more likely to get 3 blue than I am to draw 3 red. There's not the same number. So I have 27 over 125. Okay, now how can we check this? Remember what we said, this distribution is supposed to add up to be 1. It's supposed to add up to be 125 over 125. So I could add my 8, my 36, my 54, and my 27, and that should come out to 125. And if it didn't, I would know something's not right here. Okay, so now let's use this. Let's look at the probability applications. So this question is asking me, what is the probability that the number of blues are greater than or equal to 1? Okay, so what outcomes would work for that? 1 would work, 2 would work, and 3 would work. So all 3 of these are successes for me. So if I combine those, I have 36 and 54 plus 27, okay? That should be 117 25ths. 1/25. Now, there was an easier way to calculate that. I could have just taken 125 and subtracted 8 because this is the only outcome that's not going to count as a success. So I know I start with a whole 125. If I take this away, then I've got everything that's left. Okay, complementary there. So if I take the probability of 1, that's where this is coming from, and I add the probability of 2, and I add the probability of 3, and this is what I'm looking at. Okay, remember, mutually exclusive events when I am willing to include more options. Okay, I'm not, obviously 1, 2, and 3 blues are not going to occur in the same draw, so they can't happen at the same time. But I am saying that I wanted the probability of any of those occurring. Okay, so same thing here. Let's read this one the way in context. Probability that the number of blue marbles in a set of two or in a set of three when I draw is greater than 1. So what would work there? What is greater than 1? Just 2 and just 3, right? So in that case, we've got the 54 over 125 and the 27 over 125. If you add those up, okay, you can, that will work. Or you could start with 117, which was less this, and take away 36 from it. That would work as well. It's just, as long as we understand where we're going with this, we should be okay. So 81 out of 125. If we wanted to convert it to a decimal, we could. Okay, that's a possibility. Leaving it in a fraction is fine. Well, it's about 0.648 if we converted this. Whereas if we had 117, which we do in the previous problem, then this is about 0.936 if we wanted to have that in decimal form. Now, it's okay to consider this in decimal form at the very end. What we don't want to do is to turn this into decimal form before we take care of the distribution table. Because if you start going into decimals up here, it's possible you're gonna have to round, which means that these won't add up to be exactly 1 when you get down here. So I would keep them in fraction form, at least until I was looking at this. So hopefully this makes a little bit of sense, okay? The only thing that is a little bit more complicated than our coin flip is that the selection of each individual marble is not equally likely. So that means we have to do some calculating with the probability, where we did not have to do that with the heads and tails of the coin. So again, I hope that makes sense. If you are unable to find your mistakes or you do not know why your thinking should have gone this way and instead went another, then you would definitely want to set up some Zoom time or talk to me during office hours. All right, have a good weekend.